begin. Okay, so this is the only section that we will cover in chapter 11, and that deals with surface, well, volume and surface area. So here we're just going to be looking at various geometric figures, and we're going to be finding their volume and their surface area. One part would be volume, the other part would be surface area. Okay. We'll talk about similarity and difference between volume and capacity. Okay. Now, in this case, volume is going to be the amount of space that a three-dimensional object occupies. Okay. So like, let's say a box, I know that's pretty much a prism. The space in it is considered to be volume. It's the amount of space that the object can contain. Now, capacity. Sometimes we're dealing with liquids, or sometimes things like sand or sugar. When it's put in a container, that's the amount of that material that the container can hold. That's what we call capacity. Okay, so that's the difference between those two. Okay. All right, volume is always going to be in cubic units. Anytime you're dealing with volume, you're going to be dealing with cubic units. And here's some cubic units of volume, like the cubic centimeter. That's the space occupied by a cube with a length of 1 centimeter, a width of 1 centimeter, and a height of 1 centimeter. So I think I have some cubes with me. Okay. So here's what a cube looks like. Oh, it's hard for you to see. Let me get a green one. Usually cubes like this have 1 centimeter, 1 centimeter, and 1 centimeter as the length, the width, and the height. Okay. And also cubic inches, same thing. Space occupied by a cube with a length of 1 inch, width of 1 inch, height of 1 inch. So a cube with the length of 1 unit is called a unit cube, and it's said to have 1 cubic unit of volume and can be used to measure volume. So let's look at, this is going to be problem number 1. And I might have to use these unit cubes here that I have to give you, so that way you can have an idea of how to answer problems A, B, and C. And each one of them represent 1 cubic centimeter. So here we want to place the cube, well, the cubes are placed on a flat surface, so some of the cubes are hidden, and we want to determine the volume of each solid. Okay, so let's say we have this. I'm doing part A just like the one that's in this on this slide. And here we're seeing this as a 2-dimensional. Okay. So let me stop sharing the screen here so that way you can see what part A looks like. Kind of looks like this. Okay. And we're going to count the number of cubes here that I have. Okay. So here, the first 3 are obvious. These 2 on the back are obvious. These 2 on top are obvious. But for these 2 to be on top, there has to be another cube here, as you can see. So already I have 1, 2, 3, 4, 5, 6, 7, and the one on the bottom makes 8. Okay. So here, 1, 2, 3, 4, 5, 6, and then these two on the top, that's 7 and 8. So for part A, there are 8 cubic centimeters here. Okay. And then part B. If you look at part B, I do see 1, 2, 3, and then there's 4, 5, and 6. But there's one both underneath these two. There's one underneath these two that's holding those two up. So that's a total of 7. So that's 7 cubic centimeters. I'm gonna try to do the one. Let me see if I can do it like, okay. All right, we got this. That's the 3. And then there's 4. And then there's 5. And then there's going to be 2 holding these. Okay, there we go. Okay. It kind of looks like this. So here we got these 3 here, and then 4. This 4 in the front, 5, 6. And then there's one more back here that's hiding back here. That's 7. Okay. So that's 7 cubic centimeters for part B. And then part C. Okay. If we were to look at this, there is 1, 2, 3, 4, 5 that we see over here. I see 6, there's 7, there's 8, there's 1 hiding a little bit back in the back, that's 9, but there is a cube back here that's holding this one. That's 10, and there's another cube that's holding these 2 up. That's 11. Okay, so that's 11 cubic centimeters. And one way to show that would be something like this. I have this. And then these 2 here. So kind of work with me on this. And then I got these 3 here. Okay. That's this looks like. This is what this looks like here. Because we got these 2 right here. There's 1, 2, 3, 4, 5. There's a 6 cube that's holding these 2. So that's 8. And then these 3, 9, 10, and 11. So it's 11 cubic centimeters. Okay. All right, any questions about problem number 1? I know that's kind of difficult to see from a 2-dimensional view, but pretty much you just have to think about pretty much there's cubes hiding behind one of them just to hold them up. Okay. All right, so the symbol unit cube is just a measurement of volume represented by the space occupied by a cube with those dimensions. Length of 1 unit, width, and height each of 1 unit. Okay. Okay. In this example, we're going to look at the equivalency of cubic centimeters equaling to 1 inch. Okay. Okay. Somewhere you might have learned somewhere, and I didn't, unfortunately, bring some type of table that has the equivalent of centimeters to inch. For every 1 inch is equivalent to 2.54 centimeters. Okay. And we're treating centimeters as a variable. So similar to the variable a in the equation, like 2a, and we raise that to the third power. Of course, 2 to the third would be 8, and a to the third would be a, even though we have centimeters later labeled. If 1 inch is 2.54 centimeters, then 1 cubic inch, we just have to cube the 2.54 centimeters. Okay. So here we're cubing 2.54 centimeters all the way through. On the next slide, you'll see that if we cube 2.54, that's approximately 16.4 cubic centimeters. So here, a cubic inch is equivalent to 16.4 cubic centimeters. Okay. Because of the fact that 1 inch is 2.54 centimeters, we just cube the left and the right side. And another way I can do that is just this. Since 1 inch is 2.54 centimeters, I'll just go ahead and cube both sides. So here, 1 cubic inch, we take 2.54 and cube that, and we take the centimeters and cube that as well. And we come up with 16.4 approximately. Sixteen, 2.54? Yeah, yeah. Mm-hmm. Okay. I mean, if you have your graphing calculator, you could. Okay, or, you know, you can do 2.54 times 2.54 times another 2.54. That's what that means.
Oh, just 3 times.
Yeah.
Okay.
Mm-hmm.
Not times 3. 2 times.
Times another 2.54. All right, any other questions? Okay. All right, this is just a table of some of the common cubic units of volume, like cubic inch, cubic feet, cubic yards, cubic miles, and how they're used contextually. Okay. And this continues on the next slide as well. But cubic millimeters, cubic centimeters, cubic meters, cubic kilometers. Okay. Now let's say we have something like this. Scientists estimate that part of a Greenland ice sheet loses approximately 108 cubic kilometers of ice per year. Let's say we want to express this as a measurement in cubic miles per month. Okay. Now here we're going to show you how this is done. All right, they're starting out with 108 cubic kilometers per year. And they're writing it like this. And they're using what they call dimensional analysis here. Now, we need to express that as cubic miles per month. Well, let's think about this. 1 year is equivalent to 12 months. So here, they put 1 year on the top because they want to get rid of the years here and divide that by 12 months. And also cubic kilometers. Well, kilometers, 1 kilometer is 1,000 meters, but we're going to cube that. So here we want to get rid of the kilometers by doing this. Put the 1 kilometer in the denominator and 1,000 meters on top. And then that's going to be cubed. You'll be left with meters when this divides out. And we also know, well, or should know, 1 meter is 100 centimeters. So here they have 100 centimeters divided by meters because they want to get rid of the meters. And there is a fact that 1 centimeter, well, 2.54 centimeters is equivalent to 1 inch. So we have this, 1 inch divided by 2.54. That's also going to be cubed. And then, of course, 1 inch is 12 feet. So 12 feet is in the denominator, 1 foot is on top. And then finally, 1 mile is 5,280 feet. And you can see each one of these is cubed because we want to go from cubic kilometers to cubic miles. Okay, I'm going to need to move this up here. So that way you'll see what they've done here. They cubed everything that's in the parentheses. And then divided out those units because we want this in what they call, I know per month, cubic miles per month is what they want. Okay. Simplify all of that using the calculator, you'll end up with approximately 2.2 cubic miles per month. Okay. All right. Okay, now I'm going to do one of the problems here that's in the textbook on page 691. Starting with this one. Let's say we had 567 cubic inches. We want to convert that to feet. Let's say I want to convert that into cubic feet. Okay, so I'm going to put the 567 cubic inches. That's going to be over 1. Now, I need a relationship for inches to feet. I do know this. It takes 12 inches for 1 foot. 12 inches make up a foot. But since it's cubed, I know I'm going to have to cube that as well. Now, if I want to get rid of the inches, the 12 inches that I have here has to go on the bottom. The 1 foot goes on top. So what's going to happen here is this: I'm going to bring over the 567 cubic inches over 1 times. I'm going to cube the 1 and cube the 12. 1 cubed is like, well, it'll be 1 cubed, and that'd be cubic feet. And then that 12 will be cubed, and the inches will also be cubed. So now notice I got cubic inches in the numerator and the denominator. I can divide that out. That'll leave me with an answer in cubic feet. And I know 1 cube will be 1, so 1 times 567 will be 567 over 12 cubed. This will be 12 to the 3rd. That'll be 1728. And this will be in cubic feet. Now, as a decimal, I do 567 divided by 1728. This is what I come up with, 0.328125. And I forgot to share this with mine. Okay. All right, does everyone see what I just did? I used 12 inches that's equal to a foot. And I put the 1 foot on top and the 12 inches on the bottom because I want to get rid of the inches. And it's cubic inches, so I have to cube that. So I have this 1 cubed and then cubic feet over 12 cubic inches. The cubic inches divide out, you get 567 over 120 over 1728. Divide that, it would be 0.328125 cubic feet. Okay. Questions on that? Okay. Now part B, we got 789 cubic inches. We want to know how many cubic yards is that? (789) cubic inches is equal to how many cubic yards? Okay. We'll put that over 1. And there are some things that I do know. That, of course, 12 inches is equal to a foot. I also know this, 3 feet is equivalent to 1 yard. Okay. So now let's go from inches to feet and then from feet to yard. So I know the 12 inches, to get rid of the inches, the 12 inches has to go on the bottom. 1 foot has to go on top. And it's going to be cubed times. And I want to go from feet to yard. So that means the 3 feet, which is what 1 yard is equal to, goes in the denominator. 1 yard has to go on top. That 2 has to be cubed because I'm dealing with cubic units. All right, if I simplify this, this will be 789 cubic inches over 1 times this 1, everything in the parentheses has to be cubed. So it's be 1 cubed, and then feet cubed, and then 12 cubed, inches cubed, times 1 cubed, and then cubic yard, divided by 3 cubed, and then feet cubed. Okay. So when I do that, these cubic inches divide out, cubic feet divide out. I'm going to be left with cubic yards here. So that means, well, 1 cubed is 1, 1 cubed is also 1, so 1 times 789 would be 789 divided by 12 cubed. I found that out to be 1728 times 3 cubed. That's 3 times 3 times 3, that's 27. So now I'm rounding this answer off to 4 decimal places. 0.0169. Okay. And this is in cubic yards. I need to add that as well. Okay. Questions on that?
The denominator is 12 cubed times 3 cubed.
Yes.
Okay.
Mhm. Any other questions? Okay, we'll stop right here. I'll pick up with the rest of this on Wednesday. Okay. Now I'll try to give you some type of handout that deals with those units of measurement and their conversions on Wednesday as well, because I realized that might have been a little bit difficult for you to convert. So we'll talk about that more or less on Wednesday. Okay, for those of you who are on Zoom, make sure your name is in the chat room. Okay. Also, for those who jumped on late, don't forget about quiz number 4. It is open in WebAssign. The due date for that will be on the 17th of April. That's this coming Saturday. Quiz number 5 will be open on Wednesday. The due date for that will be on the 21st of April. Also, exam number 3 will be open on Sunday, the 18th. The due date for that will be on April 24th. Okay. All right. Thank you so much and have a good day.
Thank you.
Mhm.